This is lecture 4, part E, and so this is essentially an introduction to experiment 2. Okay, experiment 2 is essentially implementing the program counter. And the program counter, that includes kind of the support circuitry, which is essentially that muck sitting in front of it. So the whole purpose of the experiment is to implement program counter and have it interface with memory. The memory is another module. It's provided for you, stores a short program, and we'll talk about that in a second. So this one is not an experiment you're going to synthesize. This is a simulate only. The only thing you submit is going to be a timing diagram that's nicely annotated. We'll talk more about that later. So essentially, it is a counter, but it's not. It's actually really a register. It has 4 mux inputs. That means I want to be able to show that I can load each of those 4 inputs into the program counter. And additionally, one of those inputs, what I'm going to be doing is stepping through memory, which means adding 4 each time. I want to be able to show I can do that too. So this is the program counter that you're going to design. I tell you, use a register, don't use a counter, because it's not actually counting. It's just loading values into it. Okay, these are the values it's going to load. What you're going to do for this thing is kind of design your program counter, hook it up accordingly, and have it interface with memory. So the memory is provided for you. Not a big deal here, but I purposely didn't put all the extra information in this thing. So you're going to have to put these two together. So the issue is all this PC mod went into here, and these 3 inputs are going to be these 3 inputs on the outside. So what you're going to do is it doesn't have the ability to jump or anything. I just want you to hardwire these to values and show that you can load those values into the program counter. And you're going to show that by showing them on the output of the program counter. So the other part of this experiment is working with the main memory. So the model's provided. Essentially, the model holds the memory holds the machine code. Part of that the machine code is loaded into that memory by reading a file. So the file comes from the output of the assembler. And so what you're going to do is, there's a couple more instructions in the experiment itself, but you're going to fire up the assembler. There's a program written for you inside the description of the experiment in the lab manual, which is on Canvas. You're going to take the dump file for that, which is the assembled program. It's essentially a code full of hex values. You're going to put that in the memory. This special file, you're going to put in a text file and name it this. Okay, so once you do that, you're going to include that in your Vivado project. So as it turns out, a .mem is something special for Vivado. And so once you include that in your project as a source, it's going to fire up and put in the right place, and then you're ready to go. And so it's once again the memory model is going to read from that file, and it does so. There's nothing special you have to do for it except just stick it in there somewhere, put it in your Vivado project. So like I said, there's a lot more details in the experiment itself, certainly more procedural details and what you want to submit on this thing. The simulation, I know some people haven't simulated anything in a while. There's a cheat sheet on how to set up a test bench. It's out on Canvas also. Go check that out. More importantly, it's one of the things, all these experiments you want to get started as soon as possible on, because when you have questions, I like to be able to answer those questions sooner rather than later. So take a look, get the questions out there and answered. And lastly, once again, these are the 2 things, essentially the 2 modules you're implementing in this thing. This is provided for you. You're essentially putting this together. There's extra information in there. I even you know, you're not going to use the whole memory, but I'm going to I provided you with the instantiation template in the experiment itself. By all means, use it. People didn't use it last quarter and they ended up having problems, and it's all set up for you to make it easy. And that's all for this video. Good luck. Ask a lot of questions.